Hello to everyone. In this video, let us discuss chemical properties of second A group elements. That means alkaline earth metals. Okay, let us see here. So, what are the chemical properties here? First one is reaction with air. Reaction with air and also water. So, see here. Now, when alkaline earth metals react with what? That means which one? Oxygen or with air, they form which one? Oxides and nitrites. But in this, one important thing, let us come to know what is that. Beryllium and magnesium are chemically inert to which one? Oxygen and nitrogen. They are chemically inert. But if you consider powdered beryllium that burns brilliantly with dazzling brilliance when ignited in atmospheric air and produces which one here? BeO and Be3N2. And similarly, magnesium also, of course, in that powdered state, that also burns with dazzling brilliance in atmospheric air on ignition, and that also forms which one here? MgO and magnesium nitride, Mg3N2. So why these? In normal state, of course, in powdered state they are highly reactive, but in normal state they are which one? Means they are very inert. They show inertness to reaction with air. That means air. That means with oxygen and nitrogen. Of course, but remaining alkaline earth metals readily react with air and they produces oxide and nitride. And another one here, when these metal, that means whenever these metal oxides, alkaline earth metal oxides react with water, or even alkaline earth metals react with water, they give which one? Means hydroxides with formula MOH taken twice. Now here the stability of hydroxides increases from which one? Beryllium to barium. The thermal stability and solubility in water increases from beryllium hydroxide to barium hydroxide. So this is regarding which one here? Reactivity of alkaline earth metals with air and also with water. Okay, then after that, reactivity with hydrogen. What are the products? Let us see here. Except beryllium and magnesium, remaining alkaline earth metals directly combine with hydrogen and form which one here? Hydride of formula MH2. Then how we can prepare beryllium and magnesium hydrides? Let us see here. But these two hydrides are prepared by the reduction of their halides with lithium aluminum hydride. So let us consider here beryllium chloride when reduced with lithium aluminum hydride, we get beryllium hydride, lithium chloride, AlCl3, aluminum chloride. So like that, beryllium and magnesium hydrides are prepared by the reduction of their corresponding halides with lithium aluminum hydride. And one more important thing here, beryllium hydride, that related to that, it is covalent in nature and having polymeric structure. So beryllium hydride is covalent polymer, and ionic nature of these hydrides increases from beryllium hydride to which one? That barium hydride. So that order is here: beryllium hydride less than, magnesium hydride less than, calcium hydride less than, strontium hydride less than, barium hydride. So this is the order of which nature? Ionic nature. So this is regarding reactivity with hydrogen and hydrates of alkaline earth metals. Okay, then reactivity with which one? Halogens. So how they will react with halogens and what are the products? Let us see here. Now all these alkaline earth metals react with halogen and form which one? MX2 type of halides. And in this also one important that one important thing we have to remember. What is that? What is the that best route to prepare beryllium fluoride? What is the convenient method to prepare beryllium fluoride? Is thermal decomposition of NH4 taken twice BeF4. On thermal decomposition, this forms beryllium difluoride. So this is the convenient method to prepare BeF2. And BeCl2 also conveniently prepared by the reaction of BeO plus coke and Cl2. These three will react and produces BeCl2 and CO. So these two important things we have to remember regarding which one? Halides of alkaline earth metals. And another thing here, beryllium fluoride is much soluble in water, but other halides of beryllium are much soluble in organic solvents. Of course, beryllium fluoride is much soluble in water due to ionic nature, but remaining halides of beryllium, they are more covalent in nature, so they are soluble, much soluble in organic solvents like which one? Ethanol, CCl4, etc. Okay, another important thing, what is we have to remember regarding halides means here, let us see regarding which one? Beryllium chloride. In solid state that exists as which one? A polymer. That beryllium chloride exists as a polymer. Okay, now here let us see that which one? BeCl, Cl, BeCl, Cl, like this. In polymeric structure that exists in solid state. But in vapor phase that exists as a dimer. So we can draw the structure of a dimer like this here. Beryllium chloride exists as a dimer. So this is the dimeric structure. And on thermal heating, that dissociate into monomer BeCl2. And in this we have to remember hybridizations. In the solid state, this is having which one here? sp3 hybridization. In this dimeric shape, beryllium undergoes sp2 hybridization. In monomeric shape, beryllium undergoes sp hybridization. So these we have to remember regarding which one here? BeCl2, beryllium chloride. Okay, this is regarding which one? That halides of that second A group elements. And one more important thing regarding halides, which one? That formation of hydrates decreases from top to bottom. That means here magnesium chloride forms 8H2O, octahydrate compound. But if you come to CaCl2, that forms 6H2O, and here BaCl2 form 2H2O. This indicate what here? Decrease in the tendency to form hydrates for halides of alkaline earth metals. This is also one important thing we have to remember regarding which one? Halides of second A group elements. Okay, then let us go for which one here? Reactivity with water. So now here, when alkaline earth metals react with water, they form hydroxide and liberate hydrogen gas. They form hydroxide and liberate hydrogen gas. But here some important things we have to remember. Beryllium does not react even with hot water also, and magnesium does not react with cold water but that react with hot water, and remaining alkaline earth metals react even with cold water also. That means here what happens, reactivity increases from beryllium to barium. So like that, these alkaline earth metals liberate hydrogen gas while dissolving in water. Okay, this is regarding which one, reactivity with water. Next, reactivity with acids. So let us see what is the gas liberated with acid. So alkaline earth metals react with acids and liberate which gas, means here hydrogen gas. They liberate hydrogen gas. Okay. Then after this, what is another one here, means solutions in liquid ammonia. So in liquid ammonia they give which one, means which type of compounds, let us see here. Now consider M is second A group element that react with X plus 2Y moles of NH3, and this alkaline earth metal loses electrons and associated with which one here, X mole of ammonia. This is called ammoniated metal ion, and 2 electrons will liberate out. They are associated with which one, ammonia. This is called ammoniated electron. So like that, due to this formation of ammoniated electron and ammoniated cation, that exhibits which one, means here a dark blue color, that exhibits that color, and here these are also act as which one, electrical conductors. So this is regarding which one here, solutions in liquid ammonia. Okay, these are regarding which one here, some chemical properties of that alkaline earth metals. Now let us see some compounds of alkaline earth metals. In that the first one is which one here, carbonates. So what is the general formula of carbonates, is MCO3. As M is in plus 2 oxidation state, CO3 in minus 2 oxidation state, formula of alkaline earth metal carbonates is MCO3. And how these are precipitated or how these are prepared, means when these any compound of alkaline earth metals, when treated with carbonates like Na2CO3, we can get which one, means here MCO3 plus 2NaX. So like that, carbonates are precipitated by the reaction of sodium carbonate or carbonate of sodium with which one here, compounds of that alkaline earth metals. And in this what we have to remember here, from top to bottom thermal stability increases, because in our previous class we discussed that larger cation stabilizes larger anion, smaller cation stabilizes smaller anion. As carbonate ion is larger anion, that carbonate anion should be stabilized by larger cation like which one here, strontium and barium. That means here stability of carbonates increases from top to bottom, but that solubility decreases from top to bottom, because as size increases, stability of carbonates increases, means crystal lattice enthalpy dominates over heat of hydration. So for this reason, those solubility decreases from beryllium carbonate to barium carbonate. And of course, not only these carbonates, any compounds of alkaline earth metals, if you consider, beryllium compounds are much soluble in water. Of course, beryllium fluoride, beryllium carbonate, beryllium nitrate, beryllium sulfate. Because of which one here, in case of beryllium and magnesium, heat of hydration dominate over their lattice enthalpy values. For that reason, beryllium carbonate is much soluble in water, but remaining carbonates are less soluble in water. Okay, now, so what is the thermal stability order means? Beryllium carbonate less stable than MgCO3 less stable, so on like that. BaCO3, barium carbonate. So this is the stability order of that carbonates. Now another one is here sulfates. If you consider sulfates formula MsO4, the examples are here: beryllium sulfate, magnesium sulfate, calcium sulfate, so on like this. And these are white crystalline solids. All these are having which one, that white, having which color means white, and they are crystalline solids. And here also what happens here, solubility decreases from beryllium sulfate to barium sulfate, and thermal stability increases from beryllium sulfate to barium sulfate. Okay, then come to the nitrates. Nitrates of which one here, second A group elements. So now what is the general formula means, MnO3 taken twice. So examples here, beryllium nitrate, magnesium nitrate, calcium nitrate, like that. So these are the some examples. Now similar to first A group, that means similar to lithium nitrate, not all first A group, similar to lithium nitrate, these nitrates also on decomposition produces oxide and nitrogen dioxide and oxygen gas. Similar to the lithium nitrate, these also produces which one here, oxide, nitrogen dioxide and oxygen. So these are which one here, nitrates of second A group elements. Okay, these are regarding chemical properties and some compounds of second A group elements. Okay, in our next class, let us go for which one here, gypsum, plaster of Paris and cement. What is the composition of cement? Okay.